1, 2, 1, 2. Microphone check, microphone check. Okay, microphone works. The audience check, audience check. If you're in the room, please raise your hand. Very nice, you're in the room, you're with me. Very nice, I love it. How's the conference? Is it good? Do you like it? It's good to be back after pandemic, right? Yes, very nice, very nice. So, let's maybe start it properly. Okay, so I guess you have questions, right? You came to this room because you have questions, right? About what's this silly thing about testing, or what's this gear doing here, or why the guy has a lab coat there, but I guess the question that's puzzling you more, that puzzles you the most, is what the heck is this guy's name, right? Okay, so I'm Polish. I live in Poland. I work from Poland, right? So apparently my family name has some vowels in it. Okay, so I'm Piotr, Peter, or Peter, whatever you please to call me. Who am I? I'm entitled myself as a software gardener who has read the fantastic book called Pragmatic Programmer. Okay, the rest of you, shame on you, really. You should read this. It beautifully describes who software gardener is and why perhaps you'd love to be software gardener as well, right? Beside that, I work as a solutions engineer for a company or startup, shall I say, Atomic Jar. Who in here is from America? Just a few people. Awesome. Okay, and also work as a trainer from time to time, and I have some spare time. I share my IT knowledge or Java hints or basically poor life advices on my personal blog page called softwaregarden.dev. The question is, who are you? Who's doing Java? Very nice. Who's not doing Java, like something else beside Java? Okay, just a few people. Among Java people, Java conference, very nice. Who's running Java 20? I'm disappointed. Okay, you know I like you, Michael. Yes, very nice. Okay, Java 17. Okay, 11. Right. Pool folks still running 8. Someone below 8. No one. Okay, I love you. I mean, I'm happy you're happy. Okay, so we've met each other. Very nice. So let's shift the gears. Okay, I'm the slides now. Right. Perhaps you have a granny, or you have an auntie, or you have your mummy, right? And you love these ladies because these are beautiful ladies, they give you a lot of love and whatnot. And you're tired, right? And it's Friday afternoon, and you're after this conference, and the conference was a hell of a conference, but it was very exhausting, right? And they give you a call, look, my child, it seems that this COVID impacted me more than I thought, right? And I really didn't regain my smell, right? And I have this, how is it called? Gas stove in English, right? Sorry, it's not my tongue. I have this gas stove in my kitchen, right? And I'm not sure if it's not leaking gas. Could you please come and do something about it? I mean, you are an engineer, right? Software, hardware, doesn't really matter. You're an engineer. Please come and help me. And you're tired, you're exhausted, you're maybe intoxicated, right? I mean, conference, right? And yet you want to help the ones you love, right? Yet you want to be, despite your state, confident that you're doing something right and that it will work as it should be, right? So let's put our software developers' hats again, right? You're facing a problem, and you have to solve the problem. And what can you do then, right? You have two options. Right, buy something that's already available, just maybe customize it, mount it, and whatnot, or go for the other option, which is build something our own, right, which of course will be most costly, but at least we will not meet the deadline, right? That's very nice. So this is what we're going to do. I'm going to run this experiment with you. We're going to build what? A gas detector. Yes, that's health and safety protocol, really. It's important, lads. And beautiful ladies, yes, we have to build this. Yeah. Oh, shoot, it didn't work as expected. Nevertheless, we'll be building the gas detector. So, what do we need to build a gas detector, right? We need some kind of casing, right? We need some kind of casing. We'll be building this thing, right? And let me check if I can switch it to the cam so you can see it better. Yes. So. We'll be building our gas detector in this thing. So what do you need to detect the gas, right? You need the sensor. Of course, you need the sensor. How does it... Okay, it has some delay, sorry. So first thing you need is this gas detector, this thingy. it clicks very nice, right? We didn't build it on our own. We just found a vendor somewhere in the internet, right? Like sourceforge.net or something, I don't know. And they promise, yes, it's going to be working. It's certified. It's guaranteed to be working. So what we do, we just throw it into the box, right? We don't have to test it. It's been tested for us. It's certified. So the next thing you need, perhaps, is like power, right? We need to power the thing. So we have like a battery. It should be working, but you never be sure. So to test it's really working and providing some power, I'm going to use this mock, right? We're not really going to use it in our like detector, but I need to make sure that it has some like power, that it works. Very nice breeze, very chilly. I like it. So we have power, right? So we have the detector, like the sensor, sorry, we have the power. What else do we need, right? I guess we would need some, whoopsies. Maybe we'd need to have some sound, right? Like a buzzer or not. Let's see if this thing works. Oh, it makes it sound. Let's see if it really makes some sounds. Yeah. It seems to be working, right? Geez, maybe it's overworking. Sorry. These Bluetooth speakers, you know. Yeah, so we have like something to make the sound. The last thing we're missing is something to make the light, of course, right? So I have this lovely LEDs right here. See, they blink, bling, right? So we throw one. We can even throw two because you're never too sure. I mean, more blink is obviously better, right? And the last thing we need, obviously, is some wiring, right? You never go wrong with adding more wiring. So we toss more wiring, and then we seal the container, right? And then we call, look, Granny, I have it built for ya. Yes, this is it. Very nice. Certifying, smiling. See, it has these lovely smiles, right? Now, raise your hand if you're confident it will detect gas and you can install it in your granny's kitchen. Up, and make sure you're not a manager. I saw you, Ali. All right? Exactly. So my question is, isn't it the way, or wasn't it built the way we built software? So suddenly, when you switch hats, and when it's no longer about software, but the life, the people you love, you apply different principles and different rules. Why is that? Suddenly this is no longer so smiley, but it's so unhappy. Right? So maybe we can do something else. Maybe we can like stop bothering, ourselves, and maybe we can go for like something done properly, right? We can go and buy a detector, right? Go to like a store, the hardware store, right, and buy a detector. And now, just to be clear, I'm not recommending you, disclaimer, like asterisk, I'm not recommending you to this very particular detector. I just needed something like like the gizmo thingy in German, wie heißt what it's like to make sure it shows something, right? So we have this thing, right? It's this detector, right? See, it says it will detect like gas, and it has this lovely button. It says, come on, it says push to test. Oh, I have issues with focus. Sorry, I forgot my webcam. You have to trust me, okay? Trust me, I'm an engineer. It has this lovely button, push to test, right? So what do you think I should do before I install it at my or your granny's kitchens? What should I do? Push the button. Yeah, of course, push the button. Let's push the button. Yeah, it seems to be working. Now stop, please stop. My question is, what did we just do? What did we test?
Speaker.
We tested the speaker. Who said speaker? Okay, very nice. I already love you. We tested the speaker, yes. And we tested the button, right? But we didn't test the device as a whole. Now, do you think if there's a gas leak, right, like in the middle of the night, let's say 2 a.m., right? I don't know what time zone it is. Okay, never mind. It's 2 a.m. Do you think Mr. Gas will be so kind, so, I shall wake this old lady, let me go to the kitchen and push the button? It doesn't usually happen, right? I mean, the gas doesn't push the button. So what do? We should properly test it. So I just happen to have a very nice container. No pun intended. or intended, I don't know. Right? So I put the thing in a container, right? I seal it to be extra sure that it's not going to harm anyone. I put like another level of sealing, right? So I'll wrap it into this bag. Right, let me just open this thingy a tiny little bit. Okay, and let's put it into this bag. I don't need this mock anymore. And now what we need, who speaks Polish? Don't spoil the joke. We have to test if this thing in this box is really working, right? So what we need is Chad. And you don't get the joke unless you're Polish, right? Because in Polish, Chad is a common name for carbon monoxide. Right, so I'm going to intoxicate this thing inside, double sealed, and let's hope it will test. I mean, the test will be passed, right? And therefore, we can be sure that it will work okay at the kitchen. Let's see. It might not work. Does it work? Let's see. Okay, now, intoxicating, and now we have to wait a little. I hope the test will pass. You never know, these build pipelines.
Please open the window and the door.
It passed the test. Okay. Let's make sure we don't leak anything, right? And let's not be annoyed by the noise. Of course, if the build doesn't work, what you do, you just ignore it and you just push it like somewhere deep in your closet, right? And then you stop worrying about this. Yes. Never mind. Never mind. We've tested it. We properly sealed it. We tested it. We tested it really detects the gas, poisonous gas, right? We tested that it then makes sound and light. And now, my question would be, would you rather install this thing or would you install this thing? It's an ugly bag and this has lovely faces. Come on, people, we should know. Right? We should know. So now, we've run only one test here. Just one single test, or maybe two with this push the button maybe, right? And here, we tested every part, right? So every part is tested or certified. Yet somehow, no one, managers excluded, didn't want to install it at their home, right? So my point is, maybe we need to test our software like this, right? The software we built, the software we acquire somehow, right, from friendly teams or whatnot. Maybe this is the way. So then we can go, even after conference, without coffee or being intoxicated and exhausted and whatnot, to your granny's kitchen and say, hey, granny, I found a solution for you here. I mount it, I just plug it. I'm confident it will work, right? So I hope we've done with half of the talk, which is integration tests are needed. Someone still thinks they're not needed? Can't see a single hand. Very nice. Lovely. So now, let me show you that they're actually simple. They might be simpler than we think. Okay, enough chat. So, how much time do we have? Okay, we still have some time. Let's check how simple these tests are, right? So, test containers. Who has heard of test containers? Lovely audience, right? And yet you decided to come here. I mean, very nice, very nice. So, it's a family of open source libraries, right? Yeah, quite conveniently I have a slide picturing this, right? So the one I use the most as a Java developer is Java, of course, but there are also others. And the fun fact, the maintainers of these libraries, my work colleagues, they work together with me at Atomic Jar, right? So we do test containers and beyond. Right, and here's the page in case you need to like a starting point. How do I start? How do I learn? How to find materials to convince like my friends or intoxicate them with this good message? This is where you start. And test containers doesn't do any magic, right? What it does, basically, or what I will be doing using it, right, is relying on this or standing on the shoulder of this giant called Docker, right? So if your stuff runs in Docker, one can be Dockerized. right? I mean, not only the things you test, but also dependencies for your system, right? Like be that databases, like Kafka's, RabbitMQs, like SMTP servers, whatnot. It will work in test containers, right? Because in a way, from certain perspective, test containers is just a translator. It takes the language you know, be that Java, Go, .NET, and else, right? It will just translate it into calls to Docker API. Right? And this is what I like this picture, because when you see such a giant, you might get scared, right? Because it's something you don't know. Okay, you know how to like pull an image and start a container, and maybe not much more. Especially if you're like a junior just after university or something, and you really want to like be friendly with the giant, right? Then test containers is your friend, because it makes working with the giant less scary, right? So we have needs, right? Sprint planning. We are pulling some like items from the backlog, right? And it says, of course, we're going to do that for the demo only. Please don't do that in production code. We're going to build and test, mind you, test as well, carbon monoxide detector, which should start in less than 4 seconds. Meaning, if like let's say that when I plug the power, right, it should start in less than 4 seconds. It should check registered particles every second. So let's say it should blink every second. It should blink like bling, bling, bling to reassure us that it's still working, still in operation, right? And it should raise an alarm when the level of carbon monoxide particle reaches 400 particles per million, right? It's just it doesn't make sense. Probably it's just a random number. You know, I tossed a coin and it was like 400. And yes, so we're going to build the thing. Sorry, let me go back. So we're going to build this test detector, and I just happen to have this detector built for you. Right, so this is the detector. It's written in Java, and this is my alarm level, right? I should not, I mean, when I go above this level, it should like start raising an alarm, right? And here I'll be keeping how many carbon monoxide particles I detected, and every other particles, how many I detected. I'll be using for this HTTP server, because why not? Right? Let's pretend that this is how we do detectors, right? And what does it do? You see, it's a very simple Java program. What does it do? It goes like with main, right? And I'm printing in like this log fmt format. Who's familiar with Go? Okay, so this is like a format for Go, and I like this format. And if you like need a short intro into Go, being Java developer, I gave a talk like a year ago on this stage, intro to Go for Java developers. Nevertheless, it needs to have a port in system environment, right, to know where to listen. So we're creating a detector, listening on this port. Then we tell it start operating, and then we print started, meaning that so we expect this thing to be less than 4 seconds, right? And how the detector works. So it creates a HTTP server, right, listening on this port, as you see. And I'm using the HTTP server that's like since Java, I don't know, 8 or something, right? And then it's really dummy. I'm not even using any framework. It's so vanilla Java, so to say. So whenever I get post request, I'm going to capture what particle that really was, right? And if I get, then I just, just to be like more user friendly, I will prepare a report and picture or write how many particles were detected, right? So how capturing works, it's quite easy. I have this scheduler, right, or schedule executor, right? And every second, after 1 second, right, it will basically do stuff, right? It will perform this check here every second. And this is just, you don't do that in production code. I just simulate that this is like a hardware setup, like lasting 3 seconds, right? And then I start the server, and how performing the check looks like, it looks like this. It's quite simple. So we are just checking. I'm reporting when I'm checking, and I get the number of registered CO particles and all particles. I just divide 1 by 2, right? I mean the first with the second one, and then if the level is above the alarm level, then I raise an alarm. Like the raising of an alarm is basically printing to standard output. Right? It's nothing fancy for this demo. Preparing a report, really easy, text block. And how do I capture the particle? I basically examine the body of the request. If it equals CO in any case, then I increase the number of CO particles. And in other case, I say it's another particle. Oxygen, nitrogen, whatever, right? Really simple stuff. What can possibly go wrong? We don't have to test it, right? Or maybe we do. So there's this shortcut. It's a very important shortcut in IntelliJ, and I should get rewarded by JetBrains folks by saying this, because they don't say this. The most important shortcut in IntelliJ, if you're using Linux or Windows, and there's an equivalent in Mac, is Control-Shift-T. It's this. It will take you to a testing this piece of software, or if there are none, you can go and create new test, right? So this is Control-Shift-T, remember this, the most important shortcut in IntelliJ. And this is the test. So I'm going to use Testcontainers, right? And how do I do that? So after I Maven build my artifact, right? Because I want to put the artifact into a container, right? This is like approach I chose today. I see that this artifact is here, right? So I get the absolute path, and then I'm gonna need a container like this box to seal my thing inside. So I'm saying I'm gonna use OpenJDK 20, right? Because I run 20, right? You should be running 20 as well. And then I'm copying this jar file there. I'm exposing this port because this is the port that my detector is supposed to listen at, right? And then I run this command, and because I'm using virtual threads, right? Very good stuff. Gonna be public in September, right? So you should be already using it to win the race. Yeah, so the Java enable preview jar, and this is it, right? So this is how I create my container, right? And just to make things faster, I basically pre-prepared the test. So let's make sure that the first test will be running. So the whole container should start in less than 4 seconds, right? So how do I test that? So you don't have to start your container like this thing. Like you can go for a field or static field. If you have your test annotated, Testcontainers will start it for you, right? And it will be garbage collected and whatnot. For sake of this experiment, I decided to go the cornerstone, the most rudimentary way, which is I'll be controlling the life cycle of the container with these fingers, right? So I'm using try with resources. It's really old feature since Java 7. You should know it, right? Which means this resource, being the container, is available in this very block. And after this block, it's auto-closed, meaning Testcontainers will remove, sort of garbage collect this container, right? So I start the container, and what do I do then? I examine the logs, right? I split them into lines, and then I filter the lines. If the line starts with start, then I collect this line, and I'm passing then the events. You've seen I was logging like instant now, right? So I'm basically splitting it. That's why this Go format logfmt is so convenient. It's like a strict format of a log, right? Yes. And then I'm checking if the events contain starting and started, right? And there should be at least one checking, right, in between, because I know this because I've read the specs, right? Are you friends with this lovely Spanish guy called Manuel? You should be, right? Always be friends with Manuel. Yes. So then I'm extracting the starting event, which means the very first blink of the thing inside the box, right? I add 4 seconds, and if I check if the started happened like no longer than 4 seconds after, right? This is what I do. So, of course, I'm going to run the test. Maybe I shouldn't, it was passing before, right? No, let's run it, let's run it. Let's run the test. Will it run, won't it run, what do you think? Oh, it didn't, how pity. Let me turn off the presentation mode. It will be maybe more easier to operate with these panels. Let me just make this bigger and bigger, right? So these two other tests are still disabled, so I'm after this test, and it didn't pass, right? And what did it say? Oh, maybe what happened, right? So what happened, I already had this image pre-pulled, right? But if I didn't, the image would be pulled from like a public or private repository. I mean, if I can Docker pull image on my machine, Testcontainers will also like pull it for me under the hood, right? Basically. Yes, so what I'm doing here is, the container got started, you see, in like a second and a quarter, right? But I expected this log to have started, but actually it was only starting, so it didn't report as started. What could have happened? Maybe there's a bug in my detector, right? But no, it says like starting, started. So if it didn't like stall, it should like print started, right? Or maybe I'm still not quite familiar with test containers, and I forgot this thing, which is called waiting strategy. This is one of the reasons why you should be going, if you go, always, I recommend you to go or start with these modules, right? So whenever you have to run a database or Kafka or like a piece of software that already has a module, let me actually try to show you, which is here. So we have modules, right? And you see we have that many modules, and also they are like database modules, so the list is really long. So if you have anything that looks familiar, you should be running it not using generic container, but using one of these things, right? And because I'm testing generic stuff, I decided to go for generic container. And there's a thing that's missing. Sorry, they take pictures. Very nice. This profile maybe is better. Very nice. Okay. There's a concept that doesn't exist in Docker, but it exists in test container, right? I need to know when my container is seen as started, when this call should not block me anymore, my test execution, right? So by default, if I'm exposing a port, test container assumes, the library, if something is listening on this port, the thing inside is already working, right? Fun fact, not always. Because if we go back to the code here, right, you see it opens the port here. Here it opens the port because it creates the server, and the server is started here, like somewhere, it's here, started here, right? But then I put this started after the HTTP server started operating. Therefore, test containers, like there's a race basically, right? The race condition, sort of. So what I have to do, I need to tell test containers, look, waiting for the port is not enough. We also have to employ another waiting strategy, right? So you have to go and waiting for wait. I'm typing from my memory, see, for log message, and the message should be like, if I'm not mistaken, what was it, like started, right, equals whatever, and make that we're waiting for just one occurrence, and then with this, test containers should understand that the thing inside is ready to operate after it sees this line in the logs. Sorry, right? So let's rerun. Okay. Rerun. So you see the container is starting. Yes. Oh, and this time the test has passed. Right? So all the log lines were registered just as we encoded here, just as we were expecting. So there was the starting line and started line and checking line, and between this guy and this guy there was no more than 4 seconds difference, right? So I guess we have satisfied this requirement, right? So we pick another ticket from Jira, and it says, who has Jira? Okay. It's Friday, but let's keep my mouth zipped. Okay. It should check for registered particles every second. So after it started, right, it should check at least once per second. If it blinks more often, like blink, blink. If you're running BMW, your car should also blink, blink if you turn, right? Yes, please remember this. So again, I'm creating a container, I'm starting the container, I'm investigating the checking events, right? And I'm counting the number of the checking events because it's already checking while it's starting. So I have to capture how many events, like checking blinks I had before it reported as started, right? So now I'm using the part of like it comes to you with test containers, very nice. So when you have to test time, related stuff, you just don't sleep, you can use a utility, right? And you see it's like a DSL-ish, right? It's very nice. So between 3 seconds and 4 seconds, because I'll be testing like for 4 seconds, therefore I expect like to blink it at least 3 times, 3 seconds, right? So between 3 seconds and 4 seconds, after it started, I expect it to blink at least 3 times, and therefore I'm delaying this poll. I won't be checking logs every second. It's pointless, right? Wasting resources. And I'm waiting here until this condition is satisfied. So when I filter from the log the checking events, what I had before and what I have now is like the difference is at least 3, right? So what do? I run the test, of course, because I want to be sure this stuff in the container is working as it should be. I disable the test, keep it running, keep it running, keep it running. And, oh, it worked. Oh, why did it work? It shouldn't be working. It spoiled my demo, come on. Maybe I did a mistake in the code. Let me check. Mistake meaning I eagerly fixed the bug or something like this. Or maybe it like worked just by accident. We never be sure, right? Where is it? Yes. Let's. Oh, I know why it worked. Come on, I know why it worked because I'm running it here, right? So I have to like refresh my the artifact I'm building. Sorry, I had cached the previous one that was working because I tried to keep it real and I tried to make sure it works before I actually go into stage. So I was checking it in this nice coffee space, right? And I forgot to invalidate my cache. Excuses. It doesn't work. Very nice. Just as I expected. So why doesn't it work, right? Apparently, we don't know. And this is why running integration tests on your machine is so much nicer than running it on your CI pipeline, right? Because if you git commit and git push, God forbid git push force, right? Especially on Fridays. And then when you come next week and you see the build has failed and this is all you have, good luck trying to figure out what went wrong, right? So now I'm going to violate this TDD approach, right? I hope the TDD gurus won't throw hard objects, right, at me. What we're going to do is we're going to let me find the test. The test is again Control-Shift-T. I don't have to look for it in this like a file tree. I'm going here, and the test is here, and it fails more or less here, right? So what I can do, let's try if it will work. Let me put a breakpoint here, right? And let's see if it works. So yeah, no, we were not waiting here. Let's keep coming. Let's keep coming. I don't have to wait here. I want to stop at that breakpoint, right? Does it stop at that? Yes, it stopped, right? And do I have the container here in this scope? I don't know, maybe in this scope, I don't know. Maybe I messed the demo, sorry. How silly of me. Or maybe this is this async call or whatnot. Yes, we'll do that in the other, with the next thing. It will be easier than here. Yes, but what has happened is we forgot about the basic principles of mathematics. We're running out of time, so I'll show you that quicker. So what we forgot to do is that when we start the whole thing, do you think how many carbon monoxide particles do we have registered? 0. Very good. And how many all other particles we have registered? 0. And when we divide one by the other? Exactly. So we have to make sure that the all equals big decimal 0 is not. Right? So we don't try to divide if we don't have any particles registered, right? So because it doesn't make sense. So let me try to rerun the thing again. Hopefully it will pass. Come on. Any dad jokes, anyone? Good dad jokes? Okay. Do you know why we call Middle Age as the Dark Ages? They had a lot of nights. Okay. Build was successful, right? So apparently we fixed the issue, right? So it's okay. Sorry, it was really bad, I know. Yes. So let's head to another test, the last one we have. So it should raise alarm about 400 ppms, right? Right. So again, now what we're gonna do, I'm going to just intoxicate the atmosphere in this container, right? Again, and for that I'm going to use HTTP client, and I'm going to send a bunch of oxygen requests and just one CO particle, right? To see if it's really there. So I'm going to send 1,000 oxygen particles and one CO particle, and then let's say I expect the alarm to sound or be raised within 10 seconds, right? And that's it. So yeah, sorry, I wait here, and then within 1 second, 10 seconds is for like sending the requests. Yes. So and then I expect it to raise the alarm, right? So again, I'm going to invalidate my previous artifact. I ditch it, and now I run this one and make sure it's all right. Any more dad jokes? Come on. I did my share of dad jokes. Now it's your turn. No one? You're not cooperating, people, really. I mean, I understand it's Friday's morning, but come on. It's before noon, only before noon. My time, haha, sorry. See, I live in my time. Anyway. The test didn't pass. See, and we see part of the log, right? So the detector should raise the alarm because this blah 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 or that thing blah blah blah, and it didn't. So now let me, because now it would be easier, I guess, run the debug, and we shall see with this breakpoint what really happens inside this container, right? Because why do you think it didn't raise the alarm? What do you think was the reason? Okay, time for real dad jokes. Sorry? Don't whisper, I can hear you. Right? Some people were saying, for example, for previous sessions, oh, you didn't really send the requests, right? Okay, we shall see. So this is how I see it. It's like localhost, like this port, like it's 7890, right? But it's inside, so outside, because ports are mapped, yeah, for the containers. So as seen from my host, it's 49217. Let's see if that works or what we'll provide. curl HTTP. Come on. HTTP. See, I'm not good at using laptop keyboard. Localhost, because it's running on my localhost, and then it's like 49217, right? Sorry? Oh, local. Yeah, in Germany we say localhost, but that's okay. Apparently, anyone from Germany? Sehr gut. Ich liebe euch. Yes. So see, I registered one particle and 1,000 other particles. Still, it didn't raise the alarm. Why? Am I stopping here? Yes, I'm stopped here, so I can also go for the container. See, now I can go and let's Alt F8, because the container get logs, right? And my logs are, if I evaluate this, the logs are, let me view. It's checking every second. So it registered. You see, I was able to freeze everyone because I'm debugging integration tests on my machine, right? So apparently it's checking every second. We didn't trust our test. Now we see the log. It's checking every second. It registered 1,000 other particles. So why doesn't it work? Because, excuse my French, we suck at math. Really, or big decimal. So when you divide an integerish big decimal by an integerish big decimal, it will produce you an integerish result, right? That's the point. So we need to make sure that it's also taken into account, like the fractions after comma, right? So let me, that should be scale, what was this? Alarm level dot scale. Yes. So I'm telling it right now, if I go for a Java doc, remember it was this? Yes. See, I need scale. Always be friends with manual. I'm telling you. Let's try to run this thing. Let's try to run this thing again, right, and see if it works. First test. Next time, I will ask for volunteers at the beginning of the talk to just Google in advance or DuckDuckGo in advance some dad jokes, really. So we'll be entertained while we wait for the build to finish, right? Okay, it finished. Haha, very nice. We've done everything from Jira, right? We are done. All the requirements are satisfied. Where was this? This was site. Yeah, very nice, very nice. Except it's Friday afternoon and the manager rushes in and he said, sprint, what sprint? Forget about it. It has to be a native thing. We can't afford to run it in Java because Java is like, ooh, Java is terrible. And I really didn't prepare it for this slide because I was just, earbust about this thing. That it can be Java because Java is too costly. With the hardware won't handle it. It has to be like a native thing. So Piotr, I'm really sorry, but forget about the privilege of using like Java files and everything, right? And you might be wondering, so what are we supposed to do now? There's like this frenzy. What are we doing now? Because we have to release it like today because it's Friday and the CEO really wants to push the button, right? Ship it. And we don't know. So one guy starts shouting, we should rewrite it to Rust, right? And you throw it out of the window. I mean, the guy. Because, come on. And then it quite conveniently, one of the friends you're working with, turns out he was working previously for Ground people, right? So he tells you native image all the things, right? And you'll get an executive. And this is what he does. He sends you an executive. Like they have this detector. It's like a ground native image. We won't run it here because it will take like 2 minutes. I mean, come on, right? I just have it here prepared, right? And you might be wondering, okay, but how do we test it? How do we test? I mean, all our unit tests are basically now worthless because it's different technology. How do we, no way we can ship it, right? Or maybe it will work, maybe we won't. What do we do? And then you come and you say, relax. I've been to DevOps UK. I know how to test things properly, right? So then you're going to say, look, we're not going to test it with OpenJDK because it's like it doesn't have glibc, so it won't work. First, we will need to send this file there. So I'm really experimenting now. It's like it's the first time I'm doing this. So keep your fingers crossed. And the file is called detector, right? Because it's like native binary, see this thing. So I have this exe, let's say it was like, I'm working on Windows, I'm not, but let's pretend. And I'm just going to test it on Ubuntu 22, it was 2204, right? And then I'm going to copy not the jar file, but the exe file, and I'm going to copy that to detector. And then I'm doing this, and then I'm not going to call Java, but I'm basically going to call it basically this executable, right? And now, oh, come on, see, I'm really stressed, people. I'm really stressed because it's Friday and I need to like ship it. Because I want to spend my weekend with my family, the ones I love, right? So now I'm going to start a different container for the different artifact I'm supposed to deliver. And I'm a poor Java developer, and they want native thing. Come on, right? So let me run the test. Maybe it will run, maybe it won't run. I don't know. I've never done this before. Like honestly, it's the first time. So now you see, I'm starting Ubuntu image, right? Now I'm also like, of course, like the Ryuk was started. Ryuk is our death angel. It's the garbage collector of test containers. But come on, look, people, what's happening with these tests? They're passing. See? This is the true power. Some call it golden, that they aren't integration tests anymore, but golden master or golden standard tests. I describe how my system should behave from above. I provided it with dependencies, like listen this port, right? I connected to it with my HTTP client, and despite it's no longer Java, right? But native binary, and now we can go and rescue this poor guy that we threw him like through the window and say, okay, now we have time to rewrite it to Rust. Because we have working specification, right? We have confidence. Whether it's Java, not Java, we can now ship it, right, with confidence. I can debug it on my machine. I can shorten my feedback cycle. I don't have to like wait for the CI mills to process it and output me send me just some output, right? And then I end up next day adding debug 1, debug 2, and still it doesn't work. And week after I'm debug here for real, and I still don't know what failed because I can't debug the thing, right? And you might be wondering, okay, very nice, but I don't have that beefy machine as you have, right? Because you have beefy machine, you have like 12 or 16 cores, you have lots of RAM, or like the system I'm running, it's not a simple Java thingy. It has to be run in Docker and it has like other dependencies that also have to run in Docker. So I have Docker and Docker issues, right? Or perhaps, I want to run concurrent builds on my CI machine, and it's this old, poor Jenkins server somewhere in our basement or attic, I don't know, right? And it's not able to run multiple builds if they're so container, therefore resource heavy. So stop this madness. And then I come and say, you can do one more thing. And this is what triggered the maintainers of Testcontainers library, Java, to become founders of Atomic Jar, right? We are working on this thing. And you can scan it, and you can, because we're in public beta, and you can go for a free trial, free as in we won't ask you your credit card number, so you won't be billed the next day, right? And if you do this, you can still go to our booth at 15 something and win. I mean, this and like extra check, right? Because you have to register and there's like a raffle. But after you've done this, it will be easy. Really, trust me. And what does it do? It allows you to install a little Testcontainers, see, a little agent, like this little dude. Come on, they released a new version yesterday. Come on. See, I didn't update. Still, what does it do? When my local test or my CI test discover like this guy wants to start a container, it won't be started on my machine, it will be started in the cloud, right? Therefore, it will be using cloud's silicon, like the CPU and what's it called, RAM and whatnot. It's properly configured. We provide you with really nice dashboards to give you more insights how things should be running. So it's not mandatory, right? It's an extra step. And like we can provide you with open source libraries for free because we really believe at Atomic Jar in open source. Unfortunately, someone has to pay for the cloud, right? And we're not that rich yet. Right, so this is it. Yes, I encourage you to go to testcontainers.org should you have more questions, right? We have like the whole department, a few wonderful guys working on open source software. So should you have more questions, you can go for Slack, GitHub. You can ask us at Stack Overflow. Their job, literally, is their job to help you, to help us developers, right? With this darn thing. If it doesn't work, or if you have questions like, is this really the way I should test my stuff, my software, right? Yes, very nice. It's already used by some people, as you can see, and they don't seem to be complaining. Yes, very nice. And you might be like in this mode, like, okay, it's very nice, but I won't be able to convince like my colleagues, my friends, my boss, or whatnot. So please let me introduce you to my boss. Ellie, could you please say hello to people? Stand and say hello. Yeah, this is Ellie. Ellie is on booth duty, and Ellie has promised me, really, that if you gather 20 people in a room, I'm allowed to go and give like a whole day workshop, right? For free and whatnot, so I can go and so come to our booth, talk to Ellie, and Ellie will like arrange things so you get like in the front of the line for the workshops and whatnot. If you really believe Testcontainers or you suspect Testcontainers is the way for your company to go. And now we are reaching the end of this presentation, and I do it every time when I give a talk, Testcontainers or not, like Java, Go, whatever. And you should be doing this, people, for every speaker, for every conference and meetup. Provide your feedback. Share what you liked, what you didn't like. Rate the talk. Let the organizers, let the speakers know what was okay, what could be improved, and so on, right? So always, everyone, provide feedback. I accept today feedback in any form, could be even written form, right? You should have this DevOps app, right? So this is like the thing you should be using. If you don't have it, or you're watching this on YouTube, even like weeks or months later, you're more than welcome to go and feel I don't know in which corner I will end up on YouTube. Sorry. So the link is somewhere out there. Please make sure you fill this poll, and you can also like if you don't have desktop DevOps app, please go for this link as well. Yeah, and don't forget to hit the subscribe button. Yes, of course it's DevOps UK channel, right? As you can see, the picture here, maybe it's gross. I'm not trying to tell you that we should put the testing pyramid upside down. I'm not trying to tell you that you should abandon or ditch unit tests, right, without real dependencies, right? They're very useful. Like, if you can test that this little light doesn't work, just the light alone, it doesn't make sense to assemble the whole container and test the whole container because it's costly. That's obvious, right? So in a way, this is an optimization. So you have like a shorter fallback cycle before you test everything, right? So these tests are still needed, but these tests alone are not enough, right? So to get ultimate confidence that you can ship your stuff on Friday evening, apart from this, you should also be doing this. Therefore, I say the testing pyramid, as we used to know it, no longer exists because the systems are also different these days than they used to be. Now, thank you very much. Dziękuję bardzo. If you fancy to follow me on social media, please do so on Twitter or on Mastodon. That would be all for today. You can still meet me for like 2 or 3 hours before I rush to the airport. Thank you very much. Wash your limbs, stay safe, and test your code.